Could humans hibernate through space travel? In science fiction, space travel has a very convenient trick. You climb into a pod, the glass closes, mist fills the chamber, a computer says something dramatic, and then you fall through the impossible part. Years pass, maybe decades, maybe an entire lifetime for someone back on Earth. But for you, it feels like you're closing your eyes on one world and opening them near another. No boredom, no aging through the journey, no months of floating in a metal can, eating packaged food, losing muscles, arguing with five people, and slowly realizing that space is mostly nothing. Just sleep, wake up, arrive. It's one of the cleanest ideas in science fiction. But could it actually happen? Could humans hibernate through space travel? The honest answer is strange. Not the way the movies show it, but maybe not completely impossible either. Because nature already invented a version of this. A bear can spend months in a den, and a ground squirrel can drop into a deep low energy state. Some bats can even slow themselves down when food is scarce. Tiny hummingbirds can enter torpor overnight to survive cold temperatures and save energy. Torpor is the key word here. Not sleep, torpor. Sleep is something your brain does every night. But this is much deeper. In torpor, an animal lowers its metabolism, its body temperature may drop, its heart rate slows, its breathing slows, its energy use falls. It's not dead, it's not frozen either. It's not unconscious in the ways movie imagine. It is alive, but running on a much lower setting, like a phone switching to extreme battery saver mode. The screen is off, the apps are paused, the battery drain slows down, but the system is still alive. This is what makes scientists interested, because space travel has a battery problem, not just electricity, human battery. A human body is expensive to keep alive. Every astronaut needs oxygen, water, food, temperature control, waste management, medical monitoring, exercise equipment, space to move, space to sleep, space not to lose their mind. And the farther you go, the bigger the problem becomes. A trip to Mars can take months, not hours, not days, months. And during that time, astronauts are not just passengers. Their bodies are being changed by space. In microgravity, muscles become weak because they do not have to fight weight. Bones lose density because they are not carrying the same load. Fluids shift upwards, the heart adapts, sleep can suffer, radiation exposure becomes a serious concern. Isolation becomes a psychological problem. So, the sci fi question becomes less silly than it sounds. What if astronauts do not have to stay fully awake for the whole trip? What if you can slow the human body down? Not freeze it, not pause it for centuries, just reduce its needs for part of the journey. That is the real scientific version of the sleep pod, not frozen for 120 years. More like, can we safely place a human into a controlled low metabolism state for days, weeks, or eventually longer? And that question is being taken seriously. NASA has supported advanced concept studies involving torpor for Mars travel. Researchers have proposed habitats where astronauts would spend parts of mission in a torpor-like state. The reason is simple. A sleeping crew might need less food, less oxygen, less living space, less waste handling, possibly less psychological support. If the crew is less active, the spacecraft can potentially be smaller and lighter. And in space, mass is everything. Every kilogram you launch costs energy. Every extra room needs structure. Every supply needs storage. Every system needs backup. A small aircraft is not just cheaper, it may be different between a mission that works and one that becomes impossible. So the dream is not really about laziness, it is engineering. If human needs less, the ship can carry less. But here is where movies cheat. Animals that hibernate are built for it. Humans are not. A hibernating animal is not just sleepy. Its body has special ways to survive the low energy state. It can slow metabolism without destroying it itself. It can manage low body temperatures. It can protect organs. It can avoid some of the damage that would harm a non hibernating animal. Some hibernators can go long periods without eating. Some can avoid extreme muscle loss. Some can survive conditions that would be dangerous for humans. And then somehow they wake back up. That last part matters. Entering hibernation is only half the trick. Waking up safely is the other half. Because if you lower a human body's temperature and metabolism too much, things can go wrong very fast. Blood can clot, the heart rhythm can become unstable, the immune system can weaken, muscles can waste away, pressure injuries can form. The brain may not tolerate the change. Organs may not recover cleanly. A bear can do bear hibernation because it's a bear. A human cannot simply copy paste that program. This is why a real version of this would probably not begin as months of deep hibernation. It would start smaller, maybe controlled cooling, maybe sedated torpor-like states, maybe cycles of reduced metabolism, maybe days at a time, not years, maybe partial torpor, not full sci-fi suspension. And we already have a tiny medical doorway into this idea. Doctors can sometimes cool patients in a controlled medical situation. This is called targeted temperature management or therapeutic hypothermia. It has been used in some cases after cardiac arrest when doctors are trying to protect the brain after blood flow has been disturbed. But this is not hibernation. It's not a space pod. It is not something you do casually. It's a medical intervention with risks, monitoring, and limits. Still, it proves one point. Human metabolism can be deliberately altered. The body is not completely fixed at one speed. The question is whether we can control that speed safely, deeply, and long enough for space travel. That is the hard part. Because space adds problems medicine does not solve. In a hospital, if something goes wrong, doctors are there. On a spacecraft halfway to Mars, help is millions of miles away. The system has to work almost perfectly. The pod would need to monitor temperature, heart rhythm, breathing, oxygen, blood chemistry, hydration, nutrition, muscle condition, infection risk, and probably more. It would need to prevent clots. It would need to move the body enough to avoid damage. And then there's the terrifying question. What if one person wakes up and other do not? Science fiction loves that scene for a reason. Because waken is not just open your eyes. The body has to return to normal function. The brain has to restart cleanly. The muscle has to handle the shift. The immune system has to recover. The person has to be able to think, move, and make decisions. A crew that wakes up weak, confused, and medically unstable near Mars is not useful. They are in danger. So human hibernation has to solve both sides. How do you slow the body down and how do you bring it back up? There is another problem movies ignore. Hibernation may save supplies, but it does not make space safe. Radiation is still there. Deep space is full of energetic particles that can damage cells and DNA. Earth protects us with its magnetic field and atmosphere. A spacecraft traveling to Mars does not get that same protection. Would torpor help with radiation damage? Maybe in some ways, maybe not enough. Scientists are still studying this. Some hibernating animals show impressive biological protection during low metabolism states, but humans are not proven to have those protections. So, a sleep pod would not replace radiation shielding. You still need a safe spacecraft. You still need shielding. You still need mission design that reduces exposure. The pod is not a magic. It is one possible tool. There is also muscle and bone. Astronauts already exercise in space because microgravity weakens their body. If someone is in torpor for weeks or months, they are not exercising, so the pod would need another solution. Maybe electrical muscle simulation, maybe artificial gravity someday, maybe periodic waking cycles, maybe drugs or mechanical systems that reduce muscle and bone loss. Nobody wants astronauts to arrive at Mars perfectly rested but unable to stand. That would be an expensive nap in history. Now, if you're being strict, the answer to can humans hibernate through space travel is no, not yet. No one can put a healthy astronaut into months long safe hibernation and wake them up ready to work on Mars. The technology does not exist yet. But if the question is the idea scientifically ridiculous? No, it's not. Because torpor is real, metabolic suppression is real, medical cooling is real, animal hibernation is real. Space agencies and researchers are genuinely interested in whether controlled torpor could help with long duration missions. The fiction is not built from nothing, it is built from a real biological trick that humans have not mastered. And maybe that is what makes it so interesting. The future of space travel might not only be faster rockets, maybe it is also slower bodies. Think about that. For most of space history, we have imagined the solution as speed. Go faster, build bigger engines, cut the travel time, cross the distance. But hibernation asks a different question. What if we cannot make the distance shorter? What if we make the traveler need less? Less food, less oxygen, less space, less stimulation. A Mars mission is not just a physics problem, it's a biology problem. The rocket has to survive space, but so does the animal inside the rocket. And humans are animals, complicated animals, social animals, warm animals, hungry animals, anxious animals, even. Animals that need gravity, sleep, food, microbes, movement, and meaning. Space does not care about any of that. So, if we want to go farther, we may have to learn from creatures that already know how to survive impossible seasons. A ground squirrel does not defeat winter by fighting it, it changes its relationship to time. It lets the world become too cold, too empty, too difficult, and then it slows down. Maybe one day astronauts will do something similar. Not frozen like statues, not dead, not asleep in normal sense, but lowered into a carefully controlled state where the body uses less, risks less, and waits. A ship leaves Earth, the crew enters torpor, the engines burn, the planet shrinks behind them. For months, the spacecraft flies through silence. Inside, the humans are not conquering space with strength, they are surviving it by becoming quiet. Then, near Mars, the pod warms, the heart speeds, the breathing deepens, the brain returns. Eyes open, and for the first time in history, someone wakes up from a nap millions of miles from home. That is the dream. But the honest version is this: human hibernation for space travel is not available today. But it may not look like movies if it ever happens. It would probably be medically controlled, carefully monitored, and limited before it becomes long term. It would not remove the need for shielding, exercise solutions, life support, or emergency systems. It would have to prove one thing above everything else: that humans can come back. Because space travel is not just about leaving Earth, it is about arriving alive enough to do something when you get there. The future of exploring the universe might not begin with humans becoming more powerful, it might begin with humans learning how to almost disappear for a little while, just enough to cross the dark.